Right, we're going. Okay, so we are starting 9.4. We are looking at sequences. Is that something you guys have talked about before? Sequences, does that mean anything for you? Yes, no, maybe, no, okay, great. I'm gonna treat it very slow, so if I'm going too slow for you, let me know, but I'm gonna act like you've never seen it before, because I don't think you have. We're gonna focus on two type of sequences in this kind of near future. We're gonna talk about arithmetic sequences and geometric sequences. The difference between those is how we go from the first term to the second term to the third term. Arithmetic is where we add or subtract to get from the first term to the second term. And geometric is where you multiply or divide to get from the first term to the second term. Okay, so let's do an example. Arithmetic sequence is something like, I don't know, 1, 4, 7, 10, etc. Those ... means that it goes on and on forever. So that just means like pretend it's going to continue on forever. In here, what am I doing to go from the first term to the second term? Adding 3. What do you do from the second term to get to the third term? What are you doing from the third to the fourth? Adding 3, forever and forever, right? The reason we have to check all of those is because if it's not the same thing that you're doing every single time, it doesn't count as a sequence. Because sequence have something that we call a common difference. And that common difference is that number that you're adding or subtracting each time to get from the first number to the second number to the third number, etc. So my common difference here is going to be 3. Are you guys okay with that? Seems to be pretty self-explanatory. I'm sure in middle school or elementary school, you guys did patterns. You're like, well, the pattern is that we add 3. We're adults now, we're big kids, we grew up and we call it common difference, okay? Now we're gonna keep kind of focusing on these arithmetic sequences before we switch to geometric. We have a formula that's gonna help us find the nth term. Nth is a certain number in the line, whether it's the 20th term or the 72nd term or the 5th term. We're gonna find the nth term, okay? And it goes like this, it's a sub n equals a sub 1 plus n minus 1 times d. I'll give you a second to write that down. I'm going to explain all of that. Okay. What I physically said right here was a sub n. A sub n. Because it's a subscript of n. The n is lower, it's smaller. It's if I did not make it exaggerated enough, those two numbers are below the a sub n, a sub 1. Same thing over here. I'm not saying ace of 1. I'm not saying ace of 1. I'm saying a sub 1. A sub 1. If it makes you happy to write it down, write it down. If not, that's just like, I want you to understand what I'm saying. Okay. So what these mean, my a sub n term is like what actually my nth term is. It's the nth term. It's the a sub 20 would be my 20th term. A sub 53 would be my 53rd term. So if I were to go down the list, that would be the number. You can think of it like as a list of students in class. If I wanted my a sub 8th term, I could say, what's my 8th student's name? So if I had my roster pulled up in front of me, I could go down and say, oh, our a sub 8 student, our 8th kid is named this. So like this is not 8, this is like the kid's name or the number. What actually is that 8 is my n over here. This is actually like the number term we want. So if I want the 10th term, 10 goes for n. If I want the 57th term, 57 goes in for n. The a sub 1 term is going to be my first term. So the first number in your sequence. And then any guesses what d is? It's d. Literally on the board. Common difference. Yeah, who would have thought that I maybe would have taught you a word and we're going to use it. Common difference. Common difference. So that's what we changed. That's what you're adding each time, subtracting each time to get to the next term. Let's play around with this formula before we get into the geometric. We're gonna come down here for letter 2A or 1A, and it says, consider the following sequences, tell what type they are, give an explicit formula, and we are actually not gonna give a recursive formula. Instead, we're gonna do this. I want us to find the 8th term. So first thing we have to decide is what type of sequence this is. Once we do, then we will use the explicit formula, and then we're going to find the 8th term. We only know one type of sequence right now, right? So it's probably going to be the type that we just learned about, arithmetic, but let's make sure, okay? What do you do to go from 3 to 7? Plus 4? What do you go from 7 to 11? 11 to 15? Plus 4. Are those such dumb questions? Is that what no one's answering me? I just want to make sure you guys understand. We have to check all of them, because if not all of them are the same, then it doesn't work. It's not an arithmetic sequence. So this is arithmetic. Arithmetic sequence. Okay. That means that I need to use my formula that we just learned above. I'm going to come back up here and I'm going to use this. I'm actually going to go write it down just so I don't forget it. And then I'm going to plug in the pieces that I know. So I've got a sub n equals a sub 1 plus n minus 1 times d. All right, we don't know what my a sub n term, because I'm just finding a general equation. So I'm going to keep that a sub n there. However, we know what the first term is. What's my first term? What's the first term in that list of numbers at the beginning? 3. Good. I do not know what n is because I just haven't figured out what number I'm doing. So I'm going to keep that as an n minus 1. That doesn't change. But then d, what's my common difference? And I'm going to keep it as just a positive 4. If I was minusing, it would become if this was minus 4, it would become a negative 4 in there. So just match whatever sign you have. All right, let's simplify. Let's just multiply this 4 to everything, and then we'll combine like terms. A sub n equals 3 plus 4n minus 4. And then we can add 3 and negative 4 to get negative 1. So a sub n equals 4n minus 1. I don't often like to do it here this way, but if we're going to simplify it, we're allowed to here. So if you want to simplify, you're welcome to. Often, I just think it's totally okay to leave it like this, because this shows me exactly what you know. You know what my common difference is. You know what my first term is. That is fine for me. Okay. Questions on that? All right, now we want to use this formula and we want to plug in order to find the 8th term. That's what the directions up there said. This was my explicit function, or explicit formula. And now I want to find my 8th term. Every time I see n, I'm going to put an 8 in now. So a sub 8 equals, my first term was 3 plus n, which is now 8 minus 1 times d, which is 4. You guys okay with that? The only thing that changed from the last time we looked at this equation is that instead of n's, I now have 8's. Now I can simplify this. A sub 8 equals 3 plus 7 times 4. That's going to be 21, or sorry, 28 plus 3 is going to be 31. What that means is if I were to make this list, I have 1, 2, 3, 4 terms already. If I went down 5, 6, 7, my 8th one should be 31. If I were to keep adding 4, adding 4, adding 4, adding 4. On the smallest like this, you're probably like, well, Miss White, it was probably just as easy to just add 4, add 4, add 4, add 4 as it was to do my equation. True, but when we do bigger numbers, it's not going to be that easy. So we got to get in the habit of using this kind of formula and using this tool that we have now. Okay. All right, last type before we go is going to be geometric sequence, which is now multiplying or dividing in order to get to the next term. So in the ones we just did, we were adding or subtracting. Now we're multiplying or dividing. So an example of this could be something like 3, 6, 12, 24, ... What am I doing each time to go from one number to the next? What, Ryan? Times 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. That is now, instead of calling this a common difference, when we're multiplying it or dividing it, we call it a common ratio. So that means that we're going to use R in our explicit function, in our formula. Okay. Our formula has a lot of the same pieces as our algebraic or our arithmetic one did. It's still going to start with a sub n. The next term is still a sub 1. But instead of doing n minus 1 times d, we're going to say times r raised to the n minus 1. Okay. Just like last time, I'll label the pieces. A sub n is my nth term, while a sub 1 is my first term. R is my common ratio. And then n is the number of term we want. Are we doing okay with that? Okay. We're gonna go down to 1b, and what do you think it's gonna be? You would have thought I leveled our class perfectly. So now we're gonna come down to letter B. What do you do to go from -2 to 1? Hint, it's gonna be multiply or divide, because that's what we just looked at. How do you multiply or divide to get down? Divide by -2, very good. And then 1 divided by -2 is -1/2, and then same thing. What's another way to say divide by -2? Times what? 1/2, very good. So divide by -2 or times, let's bring that negative with us, times -1/2. Those are gonna be our common ratios, okay? And since I'm multiplying or dividing, that tells me it's a geometric sequence. All right, so let's use that formula. We've got a sub n equals a sub 1. What's my first term in my line of numbers? -2. And then times what's my common ratio? What's my common ratio? I don't want to do -2. I made Gavin tell me what we did to multiply to get there, because that's the one I want to use. I want to use my times -1/2. So my R to be -1/2. And then it's going to be raised to the n minus 1. Can I simplify that anymore? Can I multiply that -2 times that -1/2? Why not? Why, Natalia? The exponent. The exponent, I can't do a number with an exponent, a number without an exponent, because I don't know what that exponent's going to do to it. This is as good as it gets. All right, let's, though, very last thing I want to do today, let's go and find my 8th term. So I'm going to keep that equation. I'm just going to plug in 8 for all my n's. So a sub 8 equals -2 times -1/2 raised to the 8 minus 1. That's like -2 times -1/2 raised to the 7th. I would prefer us to leave this as a fraction, but I will put this in the calculator so we can see what the decimal version is. If I were to just put in the calculator, you could just do everything that you see. I'm going to do -2 times -1/2 or -0.5 raised to the 7th. That gets you this crazy decimal, 0 or 0.015625. If we did it by hand, I'm still going to use the calculator because I truly don't know what 2 to the 7th is off the top of my head. But I could do 2 raised to the 7th. When we have exponents that we do by hand, you can think about giving that 1 or that 7 to the 1 and to the 2. So that's going to give me -2 times -1/2 to the 7th, which is 128. And then because this is like 2/1, I can simplify 2 and 1/28. And I can get 64. So it's gonna be positive 1/64. And I promise that 1/64 is the same thing as this decimal. And I just proved it. So my ace of 8, and again, I prefer fractions is 1/64, but if you were looking at the decimal, or if I gave you a decimal to start, that would be the answer. Okay, you do not have homework. We'll do more notes tomorrow.